wheels will be started with respect to the acceleration that you were giving. So the acceleration, it will get some power via the engine. If engine is absent, it will generate from the battery. So those are the two sources where the power will be started and it will be distributed to the wheels. We need to understand how these electrical vehicles formed and what is the background of history with the short information. It was introduced by the Robert Harrison in 1832 to 1839, and that is the first electrical vehicle he developed. And later, they made a small variation with respect to the charging of the batteries. So it was filed without he don't have the charging proper battery adoption during the time. So later in 1879 to 1880, the first rechargeable electric battery was developed by the Gaston Planté is from the French. That is a lead acid battery was the first introduced for recharging the battery, and it can be flexible to fit in the vehicle where the motors can start rotating. So we are able to generate the acceleration. A later part of time, the EV vehicles are introducing towards the world. It will be very difficult for the battery convention, and they made the most of the investors uh, invested their money on the IC engines, so the internal combustion engines, where it can work with the fuel, the petrol and diesel combination, and then later the batteries are required more and more lithium ion batteries and some of nickel NiMH nickel batteries. So there is a batteries where we it is used for recharging. They integrated those batteries later stages, and some of the companies like Tesla, they made the model in 2008 to 2020. Uh, that is a complete EV vehicle. It was introduced currently, and now all the companies are working towards the batteries, the solid state, because batteries are coming with the solid and liquid criteria. So how this battery's life can be expanded, and how this performance can be added to the vehicles, and how the power should be reutilized when we do some acceleration or a braking condition. It's about the regenerative braking. And currently, the companies are working on the EV. In 20, the expected 60% should be the EV vehicle, and the Tesla, BYD, and Nissan, VW. So some of the companies they started working more on the EV productions, and future perspective on the EVs. Each EV should be charged with wireless, and the battery recycling should be done, and moreover autonomous EVs. So those are the future focus should be improved and added for the EV vehicles. What are the main challenges is the battery supply. The production of the batteries are very so inefficient, and the charging infrastructures, we don't have the proper infrastructures for the charging. Like we have a stations like petrol and diesel stations. Similarly, we required the charging infrastructure as well, where that should be increased, and the production of the EVs is increasing year to year, year by year by year. Every year, the vehicles working on different models and the different features, and they are adding the more uh, in hardwares to the vehicles. It will the weight of the vehicle is adding more, and they are started working on the reducing of the hardware and improving the better performance on the vehicle. So those are some new innovation and they are adding. And apart from that, they are adding the AI, artificial intelligence and machine learnings to help the driver or passengers to make the destination safe and secure journey. And the impact of this EV will be like environmental effect, like more of the carbon emission will be reduced and noise pollution also will be reduced once if we start the EV vehicle. And it will create a good opportunities for the many people where they can work in the manufacture area and some of the renewable energies. So what exactly the EV battery it will have inside? As I told you, like the batteries, it have some lithium ion chemicals. So usually it will be having the lithium metal oxide. It have the cobalt or nickel, magnesium, iron, or any other substance. It will be a part of a cathode, and where it will be protected with the electrolyte that is covered with the aluminum foil, and we have a anode, the graphite rod. So the cathode and anode are separated by the plastic separator, and to protect the anode we have the copper foil. So these are the five layers where the battery will be manufactured and it will be placed in the vehicles so to make rechargeable. And how these vehicle recharges will be happen, usually it have the charging stations, so where the vehicles will be charged from the station point. And some of the areas like it have uh, the parking slot areas, so that able to monitor and observing the via the mobile, so how the vehicle able to park automatically and charge, it will be a part of a wireless, how it will be charged without wire or wireless, so that will be monitored from the mobile app. So those are some of the future technologies, whether it will be wired or wireless, so that can be tracked from the mobile. And some of the renewable energies which playing a major role is the solar system or the wind panels. So because the power is one main concern to charge the batteries. It should be supplied from the source. So, like the natural sources, it will give a good result for the EV charging, where this will help us to charge the vehicles from the different stations. So some of the abbreviations we should know to go in detail about understanding of the EV. CO2 is the carbon dioxide, BEV is the battery electric vehicle, HEV is the hybrid electric vehicle, ICE is the internal combustion engine, CVT is the continuous variable transmission, KERS is the kinetic energy recovery system, IVT is the infinite variable transmission, PGES is the planetary gear set, PGS and FHEP is the planetary gear set based on the flywheel hybrid electric powertrain. FW is the energy storage flywheel. MG is the motor generator. ED is the pure electric driving. FD is the fuel powered driving. EFT is the electricity fuel powered driving. CD is the charging during driving. RB is the regenerative driving. MB is the mechanical braking. SO is the start of charging. So these are some abbreviations where it will help to understand um, in detail, like when we go through the concepts in different ways. And SOC is the charger state of charging. This generally it will be understand like what is the charging percentage and how much is left. And similarly, we have a VCV is the vehicle control unit. This is a part of the hardware. FHEV is the flywheel hybrid electric vehicle. MT is the manual transmission vehicle. NEDC is a new urban driving cycle. UDDS is the urban dynamometer driving schedule. SOCH is the upper limit, means we call as a higher limit of the battery SOC. And next we have a lower limit of battery SOC, and ACC is the acceleration pedal signal. BR is the brake pedal signal. So these are some abbreviations. It will help us understand in detail to know about the EV. And generally, the EV is stands for electric vehicle. As we know, the revolution is happening towards the two-wheeler or four-wheeler or the six-wheeler of the vehicles, where it requires the internal combustion engine. So the engine is playing a major role, whether it will be a four-cylinder or the two-cylinder. So the engine will take requires the fuel to make the wheels to rotate. So generally, instead of this engine, we are replacing with the battery to make the rotation. So the battery, it's required charging always. So that will be a part of a rechargeable battery. So where the power will be stored in the batteries, it will be distributed to the wheels. So the battery is the one which will be placed on the part of the vehicle. We make it as a battery packs. So this battery packs, it will help to drive the motors. So we it will be the front traction motor. So we have the inverter. So inverter, it will convert AC to DC or DC to AC. It depends upon the motor which we use. And similarly, we have a rear traction motor with the power electronic related means the inverter we have. Similarly, we have the motor and inverter, and the battery and the inverters and the motors are playing a major role to drive the EV vehicle. And what is the EV powertrain? So usually the EV powertrain talks about how the power is distributing to the wheels. Like here, we are able to understand this is a car vehicle. So in the car, like we have four wheels. The four wheels are one part. It will be connected to the mechanical transmission. So this will be a differential. The and this will be connected to the electric machine, and we call as an inverter. So for inverter, we connected to the DC-DC converter. So the inverter, from the DC converters, we are wired to the one of the controller part, that is the vehicle controller. And we have the similarly the energy management unit. Here, the voltage, if we need to drive different speeds or the battery. So we have the charging part. From the charging, the batteries will be charged, and we need to know like what is the storage and what is the efficiency. So like the three scopes are like for the EVs: energy source, power converter, and how that power will be converted into the mechanical energy. It will be a part of electromechanical actuator. So the single line, the blue line, it talks about the controller and the sensors connection. So from the vehicle to controller or the sensor, and even the vehicle controller, how it is connected to the inverter, and other part of like mechanism and transmission. The two line, it will talks about the mechanical connection, whether the drive shaft or the shaft connection, how it will be established towards the front wheels or the back wheel, or towards the mission of the drive. And the red one, it talks about the electrical connections from the batteries and from the inverters on the electrical mission. So just this is an overview about to understand about the powertrain. So the batteries and the inverter and motor are playing a major role. So like the EVs are configured with the mostly with the batteries and some other fuel cells. So the powertrain, it will convert the electrical energy into the mechanical energy. So that means the motion, the energy which stores in the battery, and the power will be distributed to the inverters and converters, and that energy will be flowed. And the electrical, it have the a motor. So the motor will convert the electrical energy to the mechanical motion. Mechanically means like it will transmit the mechanical to the wheels. To the wheels, it will be generating. And next will be the what are the key features to drive this. Mainly, we have the drive shaft here. So the drive shaft help us to drive the wheels from the shaft. So the as we know that EV is a zero emission during this operation. Whenever the transmissioning is happening from the batteries to the wheels, it will be like a zero emission. And so all together, it will be integrated. And the powertrain, how this powertrain works. So the major components is the battery packing is required, and inverter, electric motor, and gearbox. It we required to change the set of speed. And other benefits is like we have a simple design, we have a lower maintenance, and it will be zero emission, as we know. And the marketing insight, like 70% of global electric cars will be stuck in 2023. And moreover, 98% of electric lights commercial are moved towards the EV, and we got a good sales and market purchasing on the EV. Because maintaining of the pollution, like petrol and diesel, it gives a pollution. So it is impacting, and this EV, the charging, it will be can be happen in home and in some part of charging station, where it can be saved the fuel consumption money amount, and moreover, the pollution it won't be affect. So even the ICs IC engines are replaced with the batteries in coming days. So why these powertrain designs? As we know, whenever we place the batteries and some of the hardware components in the car, the heating is a one factor. So to reduce the heat, we require some cooling. So cooling, we introducing the fans component, because when the vehicles are run for long distance, it can be heated up, and even the performance it will be reduced towards the hardware or towards the battery. And to maintain the good mileage and efficiency for long run, the design towards the EV is a very essential, and to give the good performance. So always it should have a uh, proper output when it is delivering towards the speed, and towards the mileage it should have a proper response. And the functionality, the moreover the software or hardware, it should have the accurate response and accurate driving results, so towards the battery or towards the inverter. If the future, like moreover the mileage for short duration of or long duration, we should enable some features, because whenever the some of the features are not required, so that time the battery power consuming will be added more and more. So it should be avoided. There are some enabling and conditions where the switches should be turned off during some run. So that should be like the consuming of the battery power is a very essential, that should be maintained during the vehicle driving. And how this power will be distributed from the battery. So mainly the power will be distributed to the motor, to the inverters, and that two inverters, like we should convert the DC to AC inverter, that will be the traction inverter. And next we have the DC to DC converter. It will be the high voltage DC from the battery to the low voltage DC. And so that will we are providing to the auxiliary system for lightning or air conditioning or infotainment. And moreover, it will be a part of the power delivery model, where it includes DC-DC converter with the charger, and some junction box will be placed. So, like these are some important factors of the traction converters, where it plays a major role for charging of the batteries. And some of the vehicle control unit, like vehicle control acts as a brain, because it will coordinate with the sensors and other auxiliary modules to support. And we have a power distribution unit, the PDU, where it is connected to the switches and fuses and relays and semiconductors. And moreover, the firmware and ECUs, like it will be the part of the other ECUs where the data will be exchanged. And thermal management is like the hardware which we are equipped, it will be get heated up. To cool this, we should require the thermal management system to cool the complete batteries or the hardwares in the vehicle. So how this IC, like internal combustion engines and electrical vehicles, are splitted up, like from the powertrain module, like we have an engine here, and we have the transmission medium where the gear switch can be happen, and this will be a part of the front axle wheel. So from the front axle, we have a drive shaft, and we have a clutch, and we have the fuel tank. So the fuel tank will be there, and we have the exhaust system. So the back end is the rear axle differential. So it will be part of the fuel and fuel tank where it will be distributed to the engine during the running. It means it will be a part of internal combustion. Similarly, for the EV vehicle, like it is replaced with mm, the replaced with the this will be the part of the front. We have some inverters, and we have some PCU, the power control unit, the ECU, and we have the rear batteries, and we have the motors. So just it is replaced with the engine to the batteries, and clutch and other inputs will be the same, but the power distribution happening from the batteries. So generally, with the IC engine, we have a batteries. This IC engines is uh, we required a power, so that power will be distributed from the combustion engine. To combustion For the combustion engine, we required some fuel, whether diesel or petrol, anything that will be supplied to the engine. From that, the power will be generated. So we have a generator. The generator will supply the power to the electric motor and to the batteries. So for electric motor, sometimes we require the power from the generator alternatively, and we require the from the battery, so that will be taken and it will rotate the wheels. So generally, this is high level information how IC engine have the car batteries and how it will be charging and discharging will be happening. And similarly, how all this electric vehicle works. So all this electrical works based upon the charging the battery. When you plug the plug to the charging plug to the car, so that that will be charged, uh, and then it will be stored in the battery as a part of DC powers. Once you start the vehicle, the car system will be powered off and it will be turned. The battery will supply the energy to the motor. So with the help of auxiliary system. So the person able to drive, so he should press the acceleration. When he press the acceleration, what will happen? The electronics, the means the whatever the controller we have, it send information to the motor with required speed. So that speed inputs and the acceleration inputs will be taken by the controller, and it will give to the motor. So whenever the motor speed increases, the consumption of the battery speed is also increased. So it should be balanced and it should be maintained, from that will be controlled by the microcontroller, like we say power electronic controller. So and we have some part of inverters. So inverters, it will be a AC to DC or DC to AC converters. So the here the inverter converts DC power to AC, send it to the motor, because our motors are the AC motors. So we need to convert the storage of the battery will be the DC power in the batteries. The DC power will be converted to AC with the help of the converters. With the help of inverters. So the motor, mostly it will drive the wheels. So via the transmission medium, and whether the forward or backward, that can be happen. And regenerative braking system, whenever you press the brakes or during the acceleration or a deacceleration time, at that time the some force will be generated. With that some force, uh, it cannot be, it will be utilized. So the force, whatever the kinetic force, should be converted into the electric force, and it will be stored in the battery. It is a part of a regenerative braking. So during the acceleration or braking, the motor acts as a generator, and it will capture the energy, because otherwise it will be lost. So it will be stored in the batteries. So when you are stopping the car, the usually, whatever the battery it supplies, the energy, it will be stopped, and other part of components also, it will be stopped automatically. So what are the types? So as we understood that EV vehicle required some part of motors and batteries and inverters. Those are the some components, and we will understand in detail about those components in further coming sections. So before going those components in detail, we need to understand what are the types of electric vehicles. So the electric vehicle types, we have a battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle, extended range electric vehicle. So these are the different types of vehicles available in the market, and they are emerging into the market from few more, and they are adding the technologies for this EV vehicle. So the first step is we need to understand about battery electric vehicle. So what it means? Generally, the battery electric vehicle, it consists of only the bat battery system. Battery is the one, it will be packed all together, and we have the motor. So the motor is the one which makes to rotate your wheels. So here, the motor is directly plugged to the motor. So the motor starts rotating, and we have similarly for the batteries to charge, we have the charging socket. So with the help of that, it will be charged. So to charge these batteries, we have the alternate. It will be a part of a AC car, AC charger or a DC charger. So there are different ways of charging. So we'll understood about the chargings in coming slides. So and usually the electric vehicle, it have the batteries, and we have a charging board, and we have a transmission, and we have the converter, and we have the power electronic controller, means the hardware which will control all the sensors inputs and outputs. For the controller and the inverters to cool, we have the thermal system cooling. It will cool the components that available here, the batteries or the motors or the inverters, which will be cooled. So the major factor here is, we should have the proper battery package. To charge this battery, we have a charging port, and from the batteries, the power will be distributed to the volts. So via the transmission, transmission, it will be happen for from the traction motor and some of the inverters. So and power controller will play the major role to make the inputs or outputs, and the thermal system is the one which help us the cooling of the system. So what mainly EV is, it is a fully electric, moreover no gasoline or other engines, and it is a rechargeable batteries, and it requires only the external charging. So just this is some of the example cars, like we have a Tesla model and Nissan and Chevrolet. And we have the plug-in hybrid electrical. What it means, the plug-in, it have additionally, like we have the fuel supply. So it is a part of a hybrid, so it combination of two sources. One is from the battery, other is from the fuel. So like fuel, we have the chamber, and we have the charging port to charge the batteries. So here we have two slots. One is a battery, and we have a fuel tank both. So whether it will be the petrol or diesel, anything, it will be part of the gasoline. So anything LPG, anything, it will be comes under a part of the fuel tank plus batteries. So you has to fill the tank, and later you have the traction battery package, and that batteries has been charged via the charging port. And we have the electric motor, electric generator here. We have a transmission, onboard charger, and batteries, thermal cooling, and DC DC. And the other part is like we are using the more batteries, right? Similarly, to run, we are using directly from the electrical to mechanical conversion, we are using the battery. And for the fuel to convert the liquid to electrical into motion, we required the engine, like IC engine. So like we have a IC engine, so it will convert the fuel energy into the mechanical energy, mechanical to the electrical energy, so with the help of the internal combustion engine. So how this plug-in? So mainly it is similar to the high EVs, but can be charged externally. We can provide additional fuel or liquids. It is a combination of uh, both hybrid, like hybrid, we can say like motor plus IC or motor plus gasoline. Any combination it can be, but it should have both sources. And where it able to operate short distance for batteries, and remaining short distance we can operate via the fuel. It is a combination of both. It have a certain range where it will be used. If one is absent, one other can be utilized. So, and the next will be a part of some of the cars like Toyota, and some of the Mitsubishi Outlander. Some of the cars they have this feature. And hybrid electric vehicle, like it is a part of the same. Like we have the fuel tank, like the gasoline, and we have a fuel filter. So, and we have the IC engine as well, and the exhaust system also, it will be the same. Like it is a combination of both, but here we don't have the charging point. Like previously with the hybrid, plug-in hybrid, we have the charging port, but here the hybrid, sure, it won't have the charging port. You have the fuel tanker, so once you filled it, so during the batteries will be charged during the regenerative braking system, means during the acceleration, during the uh, brake, so the batteries will be charged up. And it doesn't require any external charging as we discussed. And here, the motor, the electric motor will assist during the acceleration and low speed operation. And some of the examples of this, Toyota and Honda are the one. And fuel cell electric vehicles. Here the fuel cell is nothing but the hydrogen tanks. The fuel is filled with the hydrogen here, and we have a fuel cell stack, means we don't have the complete the battery, but it will be run with the help of the hydrogen. So as usually the batteries are some part of sources for lightning or some of the additional features to enable the batteries will be used. And we have the transmission and power electric control, and similarly the battery package will be there, and fuel cell tank, and electric traction motor, DC DC converter, and thermal system for cooling purpose. Now, mostly use this fuel cell to generate the electricity, and it will be the emission free, but it depends upon the hydrogen infrastructure, because hydrogen, uh, for making the hydrogen gas, it's a very difficult. So, and moreover, the emission of this hydrogen during the vehicle run, it will be emits only the water vapor, and the long run, but limited to the hydrogen refueling infrastructure. And moreover, Toyota and Honda, some of the companies, they started working on this hydrogen. And we have the extended range electric vehicle. It will be a part of EREVs. So it have the gasoline generator and battery, like it able to see the fuel we have, and we have the fuel pump, fuel tank, fuel line, transmission, battery, and we have the emission control models, and we have the IC. So what exactly will happen is, here the it is a combination of more IC, small IC, and the generator. And IC is not connected to any driver, but it will be battery will be used. Battery will be charged during this time. It acts like a generator. So whenever you start your vehicle from the generator, the batteries will be automatically charged, and that will be utilized for the next usage whenever you are driving it. So some of the BMW and Chevrolet old, some of the cars they started working on it. And how this vehicles will run for the when you are generating some power. So generally, like from the image, like we have a fuel tank. From the fuel tank, the power or the liquid fuel will be supplied to the engine. So from the fuel, from the engine, the IC combustion engine, the power will be distributed. This is the transmission part where you have the gear shifts on transmitting of the speed will be decided by the transmission, that will be given to the drive shaft. The from the drive shaft, the differential will be there here. So from the differential, the wheels will start rotating, whether the forward or the backward or the reverse. So that can be happen. And specifically, we know for filling of the fuel, we have a fuel tank neck. So this is about the fuel combination. And similarly, to start this fuel IC, we have some part of a battery. The battery will be connected directly to the combustion engine. In between, we have other equipments where that will be rotated. And apart from this, like we have the batteries and the fuel tanks. So the other part of mild hybrid vehicles, we have a propulsion system. Means the previous, like we don't have any charging, that we have only fuel tank, and here we have specifically charging stock and the fuel. It is a part of the combination both. And similarly, we have the engine. So engine is a high engine, so it will be have some limited features. So, and we have the fuel cell, like as we discussed about the hydrogen. So usually the hydrogen, we have separate fuel cell tanker, and that will be part of a gases. That gases will be burnt, and it will be converted into the mechanical motion. In between, we require some additional components, like we have a fuel cell, hydrogen tank, and electric engine. So the electric engine, it will drive the wheels. And to understand what is a battery electric vehicle, so battery electric vehicles are run entirely on the electricity without using any gasoline. So generally powered by the large batteries. And battery electric vehicles are driving ranges from 300 plus miles. And some of the new models are reaching even higher and higher, and they're improving the battery technology. But only thing is, it requires a less maintenance than whatever the gas or diesel or petrol engines vehicles. So most of the battery electric vehicles are plug-in hybrid to use that will be having a DC charger and to use the better mileage. And gasoline vehicle, so it like some of the it is a combination of the hybrid. So mostly it requires only some less occupancy. So here the hybrid, the power whatever we are making it for the electric vehicle, it requires some mileage, like 32 22 55 mileage can be added at one extent when we fill it with gasoline. And on other side, we have a IC engine. The engine will be depends upon the fuel that you utilize. It have some limitation of the mileage. So both ways, the electric grade, whatever the mileage or the distance, it will be uh, decided by the power it is utilizing by the wheels. Since most of the plug-in hybrid vehicles are majorly increasing nowadays. And the coming to the hydrogen fuel cell, so it requires both combination of uh, the motor. So the motor and inverter, it plays a major role. And to rotate the motor and inverter, so we require some power. That power will be supplied from the hydrogen gas. So it will be the cells, whatever they combined in the hydrogen gas from the vehicle's tank with oxygen from the air, it will produce the electricity. Here we termed as a FCEV, a fuel cell electric vehicle. So it is a beneficial for electric vehicle. So where it will give the smooth ride, and it is a good for the zero pollution. And even the hydrogen vehicles are playing a good mileage, 300 to 400 miles one tank. And even refueling also can be taken very short time. With 5 minutes of time, you are able to fill the hydrogen. So it even this utilizing of the hydrogen gas vehicles is drastically increased nowadays. And what are the fundamental parts of electric vehicle? So the components, the main components are traction battery package, DC-DC converter, electrical motor, power inverter, charging port, onboard charger, and control. Controller is the microcontroller or the ECU, and auxiliary batteries, and thermal system and transmission. So we will understand in detail about these components going forward. And The major part is the battery package. So battery package, it is stored for the DC current, direct current, where it will store the storage of the DC current. It gives the efficiency, and it gives the good mileage to the vehicle. Depends upon the size and capacity. And the electrical motor is the one which will convert electrical energy to the mechanical energy to drive the wheels. And it have different types of electric motors. We have a synchronous motor like permanent magnetic synchronous motor, an induction motor, and brushless DC motor. So inverters is nothing but just convert the AC DC power to AC power for the electrical motors and it will regulate the speed and torque. And the power electronic control module, because it is a part of the hardware and software combination, where it will manage the energy flow between the batteries and the motor, and where it ensures that whatever the acceleration will give, or during the acceleration, how the speed should be controlled or maintained, so that will be balanced with the help of a power control module. And charging system is the one, like it includes onboard charger for converting AC from charging stations or home outlet to the DC for the batteries. Like whatever the power we receive for house, it will be the AC. Like that should be converted to DC. Like we have a charging charges that charges should supplied with efficiently the DC. And charging systems, we have fast charging and slow charging. So it depends upon the mode that we choose it. And apart from that, we need a thermal management system. So it is a cooling of the batteries and the other components, and regenerative braking system, because whatever the motion means the kinetic energy, we talks about the motion. So it will capture the kinetic energy during the braking, and it will convert this motion into electrical energy to recharge the battery. And transmission is the one, like we are shifting the speed depends upon the gear. So like we have a simple single speed gearbox, and we have the direct driven, like automatic and manual. So like manual is like we need to operate individually the gear changes, and automatic is it depends upon the acceleration, the speed, and during the road condition, the automatically the gears will be shifted and transmitted. And we have a charging port. Charging port is the interface that connected to the cars and external power sources. And we have an auxiliary system. Auxiliary system are nothing but just externally, like we need to supply the power, like inside the car or the outside the car, we have some exterior interior lighting and sunroof, some of the additional features. Just it requires some battery. So that is about the auxiliary battery system. So it will be the secondary battery, we usually say. So we'll discuss in detail about those components. So battery is the one, it stores the chemical energy for electrical components, and batteries are we have the terminals. the anode and cathode. So with the help of that, we are able to connect those battery terminals to the car, and it contains packets from the image. You have the positive terminals and negative terminals, the anode and the cathode, we say. So these are connected with one, interlinked with all, and it will be packed. We say that is a traction battery pack. It will be stores the energy. The batteries, it will be part of the lithium ion battery or the nickel metal hybrid or solid state batteries that are different variants. And main factor is it is a high energy density and long cycle. We can use recycle the multiple times, and it will be a temperature control system for the thermal stability. And what is this traction battery packs? It will store the energy, and it will generate the power to the motors, and the power whatever it will store, it will be part of a DC current. And this DC depends upon the current storage. The capacity will be decided. It will be a part of a kilowatts. So mostly the batteries are designed specifically on the mileage. So if one time charges, it give 200 kilometers. Similarly, it have some lifespan where it will be charged around 2 lakhs miles. The battery can survive. After that, the lifespan will be reduced. Means it will give less mileages. It depends. So that will be a part of each component. It has a specific mileages. It is a gasoline or part or a chemical part. It has some expire, and that should be recycled. And we have a specifically the alternator is it is a converting of the electrical energy to the sorry mechanical energy to the electric energy. So it will be used, and moreover the electric traction motor, the main purpose is the electrical energy will be converted into the mechanical energy. And we have different types of motors like brushless motor, brushed motor, and AC induction motor. And it is a high torque, and it has a high efficiency. And this electrical motor, it will be operated for the driving the vehicle wheels, and it will used for drive as well as the regenerative functions. Moreover, with the help of this traction motor, we are able to reproduce the power from the during the acceleration or braking condition. And next we have a power electronic control where the power will be distributed to the motor. So it will manage the flow of electric energy from the batteries to the motor. And it what the main function is, it regulates the motor speed and torque conversion. And it manages the flow of electrical energy from the batteries to the electric motor, with respect to the inputs that we are giving from the pedal or the acceleration. So this will be managed, the acceleration or the speed that will be managed by the power electron control. And the hardwares get be heated up, the components get be heated up. To cool this, we have the thermal system. So we call as a cooling. So it will help us to cool the batteries and motors and other electric components. So we call as the coolant or the fans and heat exchange. So mainly it will maintain the proper operating condition. So with respect to the water rotates or in different conditions, and it will maintain the proper and normal temperature in all states. And next is a charging port. Charging port is specifically for kind of giving the power to the batteries. We have charging levels: level one, level two, level three, and these are the three levels. Level one is about household, like 120 volts of voltage. L2 is the fast charging, 240 volts. Level three is a DC charging. So these are the three types of charging levels we have. Charging ports, generally it have the pins. We are able to see that neutral and PP and CP will be there, like L1 and N, and L2, L3. So these are the pins which have the port config. Similarly, the pin should be mapped to the connector, so then only the vehicle will be charged. And whenever the vehicle is charging, you will get the indication of the light that it is charging. So the position, like some of the vehicles, it have the front or the back or the side. It depends upon the vehicle how the charging ports will be configured to the vehicles. And moreover, onboard charging, so it will convert AC power from the grids to the DC power, and the charging is one like it will flow the current uh, to the battery packets, and it will be saved in the battery in a different condition. So it will maintain the proper charging process. It will be in a forward charging. It won't be have a reverse charging. And we have a power inverter. Power inverter, it is a part of convert the DC power from battery to AC power for the motors. So, and similarly, it have a role of converting AC to the DC during the regenerative braking system. And power inverter, we are able to convert this DC power from the batteries to AC. And additionally, as we discussed about it, it's able to produce from the regenerative braking. And moreover, it will maintain constant speed during the acceleration or the slow up vehicle or high speed vehicles. So this will be maintained. And we have a converters as we discussed. So this will be convert high voltage to low voltage DC, like lightning, infotainment, and sensor. It will be a part of the conversion where it have different voltages will be maintained at a different conditions. So next we have auxiliaries. Auxiliary batteries are the secondary batteries we usually say. So this the main purpose is if the primary battery got a failure, the secondary battery will continue the operation for the vehicle, and it helps to prevent the high voltage drop during the engine startup, and it will help the vehicle to smooth driving the operation. And the braking system, this will be a part of a recapturing the kind, we say recapturing of the kinetic energy during the braking. So here it will convert the mechanical energy into the electrical energy, and that electrical energy will be stored in the batteries. And the transmission is the one, it will be supplied to the wheels. So during the gear changes, so with respect to the forward or backward, the transmission plays major role in the vehicle. Usually the IC engines or the EV engines, it will be the single transmission. We don't have the dual transmission, it will be the single transmission. Single transmission will be maintained together with respect to the gear changes. And similarly, we have the automatic and manual changes. And the traction motor and the traction and the transmission, the EVs usually we have the batteries and the ECU that is connected, and we have the motor gear system. So this will be the IC engine, and the transmission will be happening with respect to the shifting of the gears. So like it is a part of a parallel hybrid unit. So traction motor is the one, it have the starter and rotor. Starter is nothing but the stationary system. Rotor is nothing but the rotating component. So it will be in the motor where the it will give the vehicle make the vehicle to move based upon the speed that is generated from the IC. So means the power it is utilizing or the generating from the IC. There are two types of motors in the EV. We have the AC motors. AC motor we have a synchronous, the brushless motor, and asynchronous we have a induction machine. And we have the gearbox and transmission, as we know, like we have a manual and automatic gearboxes. And HEV powertrain, we have it have a combination of motor and engine. And next we have specifically the parallel hybrid and fully hybrid. So it will be clear that whenever the gear changes is happening, that the time the shifting or the speed changes will be changed, and that power will be distributed to the wheels. So how this power transmission is happening? The power transmission is happening from the battery electric vehicle. So it will be the distributed to the wheels. So during that acceleration will be, whenever you press the acceleration, for that acceleration the power will be taken from the battery or the IC engines. It will be distributed to the wheels. to maintain the proper edges. And what are the advantages of EV? So, environmental benefits, it will be the zero emission and reduce the greenhouse and gas emission. Cost wise, lower running cost due to the cheaper electricity compared to the fuel, and we can reduce the maintenance due to the fewer moving parts, and we have less maintenance, the motor injector and the batteries. It will be compared to the IC engines, we have less components. And performance wise, it is a like the torque provides a quick acceleration and a quick and smooth the driving experience. Energy will be like completely, it will be depends upon the battery or the gases which we use. And challenges for EV range, as you know, it have limited driving conditions compared to the IC vehicles. And moreover, the charging stations are very less. Still, then that should be grown. And cost-wise, some of the vehicles, EV vehicles are higher cost compared to the normal budget. So, because of the batteries, prices are increasing more and more, and even that impact is adding for the EV vehicle uh, to make the prices more. And battery longevity and recycling. So, moreover, the battery's lifespan will be reduced when we use for multiple times and multiple recycles. So this is also one impact. And moreover, these batteries, once the usage is completed, it will create environmental issues. So that should be avoided. And charging technologies, like we have the AC chargers and DC chargers generally. So the L1, 120 ohms plus slow charging from the standard home and outlet, and it's suitable for overnight charging also. It won't impact much on the RAM. And charging 240 volts, it will be a faster charging. We have specifically dedicated charger will be there at home, public chargers. And this is fast charging. So we have a rapid charging station for quickly refilling. We have a the Tesla. It will be the supercharger where the charging will be a faster, and within minutes of time the vehicle will be charged up. And what are the applications of EV? The transportation vehicles, passenger cars and motorcycles and bikes are coming up with EV, and public transport is electric buses and trolleys, and commercial vehicle delivery vans and electric trucks, and special purpose vehicles like forklifts and airport ground support equipments. All are coming up with the EVs. And future of EV will be the technology advancement and mostly the autonomous vehicle. So and the government policies, because some of the electric vehicles, if you purchase, the government giving subsidies is for the customers. And we are these powers are integrating with the renewable energy like solar and wind energy from the where the power will be um, collected, and from the charging station, like vehicle to grid technology, like that will be supported more. And those are the improving areas. And the improvement in structure, like even the expansion of the charging stations and towards the wireless